Morning, everybody. My name is Beth. I am a developer. I work at DS, a consulting company based in Melbourne and Sydney. And I'm here today to talk to you about Pact, which is a testing tool that can transform your testing process. And it's based on some experiences that my colleagues and I had at realestate.com.au, or REA as it's also known, where I was working for about 18 months. JB Rainsberger gives a talk which opens with the following provocative statement that I love. Integrated tests are a scam, a self-replicating virus that threatens the very health of your code base, your sanity, and I'm not exaggerating when I say your life. So why are integrated tests so hated? Well, they're slow, meaning we run them less often, and that means we don't get as good feedback on our design. And you end up with this many-to-many relationship between your code and your tests. And that means when an integrated test fails, it's not immediately obvious which line of code has caused that failure. And because of that many-to-many relationship, when one test fails, it's likely that 20 other tests are going to fail along with it. And the real killer is that if you use integrated tests to check the basic correctness of your code, the number of tests that you need actually scales combinatorially. So for example, if you had 3 classes with 4 code paths each, you'd actually need 64 tests to cover each line of your code. And nobody wants to write 64 tests. Nobody has that amount of time. So we've all had that day where we've been trawling through our code trying to work out what's made all our integration tests suddenly seem to fail at once for no apparent reason. So why do we still use these integrated tests? Well, it's because we've also all had that day where we hand over a new feature to our tester and we're feeling pretty smug because we've used TDD and we know we've got 100% unit test coverage. And the tester brings up this new page and they get a big fat 500 error. And you look at the tester as if to say, well, that's not my problem. All my tests are green. It's your problem. But you humor them anyway because it's your job. And then you look through the logs and you discover there's a record not found exception. And you think, oh, that's strange because I know I wrote the test for when the record was not found and it should behave nicely. But then you dig deeper and you realize that you did write that test. But you wrote it and you stubbed the code where the record was not found to return nil. And in actual life, it actually throws an exception. So you think to yourself, oh, if I'd written an integrated test, I would have caught that bug. So now you have a dilemma. If you don't use integrated tests, you can miss these sort of bugs, perhaps even let them go through to production. But if you do use integrated tests, you've introduced this slow, complex, burdensome load into your code base. So the question now is there another way to find these errors? And the answer, luckily enough, is yes, and it's called achieving test symmetry. Now, test symmetry is a way of checking that the assumptions that we make when we're stubbing our code are actually correct, and it works like this. We have 2 classes, A and B, and in our test for A, we use a mock B. Now, why do we use a mock? We use a mock because it helps us avoid the combinatorial explosion that I mentioned before. In our test for A, we check that A makes the right calls to B and that it can handle the responses we expect back from B. Now, this is not life-changing. This is what we do all the time. This is what we call the collaboration test. What we miss, though, is the other part of this diagram. You can see this diagram is not symmetrical. What we miss are called the contract tests. And those are the tests that make sure that B actually responds to the calls we think it should, and most importantly, returns the thing that we think it should. Now, if we could ensure this test symmetry was was correct, we wouldn't have any problems. But the problem with mocks is that they're based on our assumptions, and sometimes our assumptions are wrong. Or sometimes they start right and they become wrong and we don't know about it sometimes until it's too late. If we could just ensure this test symmetry, we wouldn't need these messy integrated tests, and we'd live in this beautiful symmetrical world of rainbows and unicorns and happiness. So why aren't we already living in this world of rainbows and happiness and unicorns? It's because achieving test symmetry is hard because there's no automated tools to do it for us. It relies on the eternal vigilance of the developer, which, just like Rails, does not scale. Oh, that's good. That joke has never worked in Sydney before. It's a Melbourne-specific joke. So even the type system doesn't always help us. And there's just nothing that will look through your code and say, well, I can see you've stubbed B over here to return this thing, and you've actually, mismatched that over here if you've missed that test. So I posed this question to my colleagues at DS and said, does anybody else know of any tools that can help us achieve this? And there was a whole lot of silence. And then my workmate Ron, who was working out at realestate.com.au at that time, said that actually where he was working, they were trialing a new tool that did something very similar to this. Now, just as a bit of background, realestate.com.au has a website that hundreds of thousands of people use every day, and they've grown really quickly to meet that demand. So it's not surprising that they have their fair share of monolithic software, which we just used to call software, but now we have a name for it. Now, that's not to say that all monolithic software is bad, but this was the bad type of monolithic software that was really tightly coupled to all the other pivotal systems in the company, and you're afraid to touch something over here because of the effect that it might have in some completely unrelated system all the way over here. So in an effort to get away from this anti-pattern, REA started writing small single-purpose services that we now call microservices. Now, microservices are really good because they help take your code and break it down into small, manageable chunks that are easy to understand and maintain, change, and even throw out. But the downside of microservices is that you're increasing the number of integration points. And when you increase the number of integration points, you increase the number of integration tests. And if integration testing within a code base is painful, then integration testing between services is even more painful. Those tests are slower and brittle and lengthy. They can take hours sometimes. And they're causing a lot of pain. So let me walk you through a couple of solutions that they tried that didn't work so well. So they started with having one integration test environment that was the gateway to production. So they had copies of all the monoliths and then copies of all the services. And then they would try and deploy everything in batches and test everything together before they'd release everything. And the problem with having one environment that's a gateway to production is when you have a whole heap of services and changes trying to get through that gateway, it becomes a bottleneck. And when you have really tight coupling between your services and you're uncertain of the effects of changes, it makes you very overprotective. And you try and test everything to the nth degree before releasing. And that makes your release cycle slow. And then if you do find a bug, it's slow to fix it. So that really wasn't working so well for them. At around about the time that microservices started becoming a thing and kind of connected to it, REA started using AWS. So the logic went that if having one gateway test environment was not working, let's try giving each service its own test environment and running the integration tests across each of those environments. That kind of worked okay for the new services which all had automated deploy scripts, but they still needed those copies of those old monoliths, and those weren't automated, the deploys weren't automated, the maintenance wasn't automated, so they had to be hand maintained. So this approach was tried for about 3 months, and there was a lot of failures, there were a lot of false positives, and only one proper bug was actually detected. So generally speaking, system integration tests are fraught with problems. They scale really badly, there's lots of setup, you might need expensive infrastructure, there's a lot of false negatives. The bugs are hard to fix because it's hard to work out exactly what part of your system has failed. And they're really slow. So let's come back to this tool that Ron was talking about that they were trialing. So this is why I'm a developer, because this is the extent of my graphics skills. Now, Pact is the tool that he was talking about. And it was written by some pretty smart people at REA and is now an open source library. And is based on the concept of consumer-driven contracts. Now, when we're designing a consumer and provider pair of services, we often start with a provider, or maybe some data in a database. And we go, well, what's the easiest way I can get that data out of that database and into a HTTP response? And often we just end up exposing our database model, which is not the best way to do it. So consumer-driven contracts turns that around and starts by asking me, the consumer, how do I want to consume this data? What format makes sense? What requests make sense to me? And then we go over and make sure the provider conforms to our wishes. So Pact uses consumer-driven contracts to automatically enforce test symmetry between the two services, and this is how it works. We have service A and service B. This diagram probably looks familiar. But in the consumer-driven contract world, we call this the consumer and the provider. And we write tests for the consumer using a mock provider that the Pact library provides. And then we check that our consumer makes the request that we think it should to the provider. And we check that it can handle all the responses we get back from the provider. Now, at this stage, this is where Pact is different from just normal HTTP mock software. Because while we're running those tests in the consumer, it's taking those requests and our expected responses, and it's writing them to a contract file. This is what we call the Pact. Then the second step of this process is we take that Pact file over to the provider, and we replay the requests against the provider, and we look at the responses that come back, and we compare them to our expected responses. And if they match, then we know that our real provider is behaving the same way that our mock provider did. And then we can be pretty confident that in real life, our consumer and provider are actually going to talk together correctly. So unlike those integration tests that we talked about earlier, contracts are fast, they're more stable, they're easier to debug, and they're more reliable. If you write them correctly, they'll scale linearly, not combinatorially. And there's a much lower setup, and you don't actually need any extra expensive infrastructure because you can run these tests on your local machine or on your CI build. Contracts allow you to develop with agility and avoid traditional versioning systems. And you're able to do this because the provider knows its consumers, and it knows that all the expectations that the consumers have of it. So you will know before you commit changes to your provider or consumer whether or not you're going to work correctly with the other service in your pair. This means that you don't have to wait for a lengthy build cycle to discover bugs. You know before you commit. So you're not even checking in bugs. And because you're designing with consumer-driven contracts, you're writing a better API because you're starting with a real-world example. Now, if you're anything like me, you don't really get a concept until you've seen a code example. And at this stage, I have to make a bit of an apology because I'm from Melbourne and we love our Ruby in Melbourne. And I didn't realize until I saw the agenda for NDC Sydney, but there's a lot of Microsoft people here, a lot of JavaScript people, but not so many Ruby people, it would seem. But I'm the first person to admit that Ruby has 99 problems, but lack of readability is not one. So I'm pretty sure you're going to be able to follow along with me here. All right. Every good test has 3 parts. Arrange, act, and assert. So this is the part we arrange. We're setting up our world. So we're going to declare that we have a service consumer, and it's going to be called the Zoo app. And we're going to write a pact with an animal service. And we're going to run a mock service on port 1234. Next, we need to set up our expectations on that mock service so that it will behave like we think the real service is going to behave. So we're saying here the animal service, given that there is an alligator named Mary. Now this is what we call a provider state, and I'll explain why we need this later. The animal service, upon receiving a request for an alligator with a GET request to path the alligator's Mary, will respond with, and we expect a JSON document with our alligator Mary, and we expect it to be a 200 response. Next, we need to do the act and assert parts of our test. So when we run our animal service client, this is the class that we're writing to interact with our animal service, we expect find alligator by name Mary to return us an alligator object with the name Mary. Then while we're running that test, our mock server is writing our Pact file for us. So it's just basic JSON. You can see we've got our provider and consumer names there. And we've got a list of our interactions. So you can see that code that we have has now been turned into JSON. We've got our description of our request, our provider state, and our actual request and the response we expect. So that's the first half. That's the collaboration tests. Now we need to run the contract tests. So we pop into the provider project, and we do the reverse of that configuration that we did at the start. We say the service provider, the animal service, will honor a pact with the Zoo app, and we give it a URL where it can access that pact file. Next, we need to set up the test data. Now, this is a really important step. Now, remember I said we had a thing called a provider state that I would explain later. Now, this is where we use that provider state. Back in our consumer project, we assumed that there would be an animal service, an alligator named Mary. Now, at this stage, we need to write a bit of code that when it sees that there is an alligator named Mary, will insert an alligator named Mary into our database and our provider. Because if we just replayed a request for an alligator named Mary without setting up any data, we'd get a 404, not a 200. So we declare our provider state, there is an alligator named Mary, and we insert an alligator into our database. And then we run our, replay all our requests and look at the responses that come back. And of course, because we're doing TDD or test first, we get some failures. But then we red-green refactor until we get to this nice, beautiful green state where we're running our verification tests and they're all green. And the text that we used when we were setting up the test in our consumer is used to create this really nice output in our provider verifications. So you can see it reads quite nicely. Given there is an alligator named Mary, a request for an alligator returns a response which has a 200 matching body, blah, blah. So this test here, when it is green, tells us that our real provider behaves the same way that our mock provider did. So it stops that drifting mock problem that we talked about earlier. Now, let me talk about sharing contracts. So our consumer and our provider, because we're writing microservices, are in different projects, different code bases, different repos. We need to get the contract somehow from the consumer to the provider. There's a few different ways we could do this. We could push the contract from the consumer build straight into the repo of the provider. Or we could use build artifacts. But there's actually another tool that's been written specifically to solve this problem, and it comes along with some extra benefits. Now, this tool is called the Pact Broker, and it's a central point for sharing pacts. Now, the benefits of using the Pact Broker when you use the same Pact Broker for all the services in a given context is that you can start to mine the data that is in those contracts in the Pact Broker to provide some really useful information. Because one of the dirty secrets of microservices is that you can't really kill complexity. When you're writing microservices, yes, you're breaking your code down into smaller manageable chunks, but then you're actually increasing the complexity of the interactions between them. And unless you have automated tools to help you manage that complexity, writing more and more services is actually going to be more of a burden than a solution. So let me show you an example of some of the information you can get out of the Pact Broker. So this is a network graph of a heap of services that were in a context at realestate.com. And there's a fair number of services that are all quite chatty, and you can actually see that service 2 depends on about 6 other services. And at that point, you might start to go, there might be something not quite right happening there, or you get useful stuff out of this that shows you where your dependencies are and what your most used services are. One of the other really useful things is this auto-generated documentation. So when you have, 5, 10 microservices, the developer team can kind of keep track in their heads of what each service does. But if you're like REA, who are now probably about 3 years down the track of their microservices, that they'll have hundreds of these microservices, and no one person can know exactly what everything does. So having this auto-generated documentation makes it much easier to work out what each service does with really clear examples, and increases your ability to reuse a service because you can see what they all do and go, oh, is there a service that already does what I want? Let me have a look through these examples. The other benefit that the Pact Broker gives you is that it allows you to decouple your releases. One of the aims that people want to achieve when they're using microservices is they want to decouple their releases so that they can deploy their consumer or deploy their provider separately without having to do this lockstep thing where we have to deploy like 5 different services all at once. Now, when you're running your standard Pact test, you'll be testing your head consumer against your head provider. But when you deploy a new version of your consumer to production, you actually want to know whether it is compatible with the production version of the provider. And then if you deploy a new version of your provider, you actually want to know whether it's compatible with the production version of the consumer. So having the Pact Broker and having these version pacts allows us to do what I call testing the Pact matrix to make sure that if you deploy one thing, it's compatible with all the other things. Because the Pact Broker has this ability to tag a pact. You can say, well, this is the production pact, or this is the test pact. And when you're doing your verification in your provider, you can say, well, I want to test myself against the head pact, but I also want to test myself against the production pact or the test pact. Now, not all services communicate via HTTP. Events-driven services are quite popular, and in fact, you can actually do REST without HTTP, which is what we did another project that I worked on at REA. So we did wrote an architecture where we're actually using batch processes to generate hypermedia JSON documents that got written to S3. And the consumers of those JSON documents needed to be sure of what the contents of those JSON documents were in just the same way that an HTTP consumer would need to be sure of what comes back in a response. This process we called hipster batch, and it worked out really quite well for much larger data sets than you would want to use in an HTTP request. So we used Pact, but not in quite the same way. When you're using HTTP, you get this really neat injection point where you can put your tests and your verification. But when you're using non-HTTP based services, you need to find that injection point yourself. But the underlying principles are really the same. So your consumer, you need a test to show that it can correctly handle a given message. And the provider, you need a test to show that it actually creates the message that you think it will. So we used the JSON matching portion of Pact to do the matching and the tests, but we wrote and then the Pact Broker to exchange the contracts. But then we wrote those little bits around the verification and the setup ourselves, and it worked really quite well. So you might be wondering now, do I still need these big integration tests now I've got these fancy contract tests? The answer is, it kind of depends on the organization's risk profile. So when we're deploying, when it comes to releasing software, there's this tension between confidence and responsiveness. Narrowing the scope of a test increases our responsiveness, but it can decrease our confidence. And whether or not that works for your organization is something that only your team can answer. But I'll walk you through what we did at a few teams at realestate.com. So we did ditch our integration tests, and it was wonderful. So then we took that time that we would have spent investing in those integration tests, and we put it into writing much more meaningful business monitoring. So we were able to know when underlying business processes were broken. This worked because the developers were the people doing the releases. We had what we used to call accidental DevOps, which was actually because we ran out of ops people. So it wasn't because it was cool, it was because it just had to be done. But there were some really good benefits to this. It means that when a developer is worried about being woken up at 4 o'clock in the afternoon, they write really good monitoring and really good tests. So contract tests work on their best within a DevOps system because releasing bugs into production becomes much less risky when you know that you can find those bugs and you can fix those bugs really quickly. So like every tool, there are problems that are suited to that tool and there are problems that are not suited to that tool. Pact is a tool for consumer-driven contracts. And if your consumer can't derive the requirements of your provider, then another tool is probably going to be better for you. Pact is really good for use with internal APIs. And it's best when you have control over both the consumer and provider. So not necessarily that you are writing both, but you are talking to the provider team, you have good interactions, you have good communication happening between those two teams. So when should you not use Pact? You should not use Pact for public APIs, because a public API is not consumer-driven in the same way anyway. Contracts allow you to develop quickly and avoid traditional versioning to achieve rapid change, but this can be done because the provider knows its consumers and it knows the expectations they have of it. And public APIs do not know their consumers. Stability is the key rather than release responsiveness. And from a technical point of view, when you run the verification, you can't actually test the API. You can't set up data in it without actually using the API that you are testing. And then you get into the situation where you can have test data leaking over from previous tests that contaminate your tests. And one of the main features of Pact is that you have complete isolation between your verifications. So never in the situation where the success of one test relies on the success of a previous test, because that ends us up in the integration test tail that we were trying to get out of. So because the Pact file itself is JSON, it's language independent. So you can write a Pact library in any language. And we're working on it. So the Ruby one was the first one to be written and is pretty stable and quite feature complete. The JVM and the Scala is the same. The .NET is pretty early days. The JavaScript one is gaining popularity, and the newbies on the scene are Swift, Go, and Rust. And they're all being kept together by this Pact specification, which means that if you generate a Pact file in a consumer, then the matching logic will run the same on a provider in any other language. So this gives you the confidence that even with services in different languages, they're all going to work correctly together. So in a summary, a traditional integration test covers many layers of our system, increasing the opportunity for failure. And by breaking our tests up into small, manageable chunks and enforcing this test symmetry, we achieve more reliable and faster running tests. So Pact allows you to combine the advantages of integrated tests and test symmetry while mitigating the shortcomings of each. It allows you to modify components with agility and give you quick feedback on potential breakages, because you know before you commit whether you've created a bug, not after a commit and a 30-minute build cycle. It ensures you always have up-to-date documentation without any overhead. And if you're lucky, you could even throw away your integration tests. So Pact makes your microservices play nicely together. And if you would like to know more about Pact, you can hit up the homepage of pact.io, and there'll be links to all the implementations, the mailing list. You can ping me on Twitter, but don't actually email me on that email address, because I'm actually on maternity leave at the moment with 6-month-old twins, and I do not check my work email very often. But you might be able to grab me on Twitter. My name's Beth Skurrie, and I would like to answer any questions you might have now.
Yes. On the producer side of those tests, where you are inserting your expectation data into a database,
Yep.
Would you usually set up the producer test as an integration test in the sense that there's a real database there, or are you doing it?
Yeah, that's a really good question, and my answer is it depends. It depends really which. There was a really great sentence that I read in one of Sandy Metz's presentations, which said, follow these rules, but break them if doing so will save money and time. So we were writing small enough services that it was just much easier to use the real database. And I've had intense conversations about whether we should be mocking just the bit behind the HTTP interface, but then you're going to need to do another set of tests to make sure that mocking matches up with and you see where I'm going? Yeah. So our services were small enough that we felt that it was just easier to insert real data into the database rather than mocking stuff. However, when one of our services did have to make calls out to another service, at that stage we thought, yeah, we really should be mocking that, and then we would have another set of contract tests between this service and that downstream service. So they're all kind of linked in together by a chain.
Hi, Beth. I've got two questions. The first is, what's your recommendation on maintaining the Pact files? Because you mentioned about the Pact Broker. So what would be a architectural model of having a Pact Broker in terms of a separate service, or we can just run them locally on each build pipeline?
I think it's easier to have one. I think it's more valuable to have one Pact Broker per deployment context. So this is another discussion we had at REA, which is, should we have one Pact Broker for the whole of REA, or should we have one per line of business? And you have to find that sweet spot based on your organizational setup. And we ended up having a Pact Broker per kind of largish group. So we actually didn't want too much chatter between the services in different organizations, in different parts of the organization. We wanted it to be chatty within the little ones that are close to each other, and then the slower conversations between the wider area ones. So we kind of had a Pact Broker per context, and that's better than having like a Pact Broker per pair of services, because you want to be able to get that network diagram out of there to work out what's talking to other things. Also the overhead. One thing I should mention about the Pact Broker is that you can get a Docker container for the Pact Broker. So the setup's pretty easy now with AWS.
And my second question is, how do we schedule tests on the consumer and provider side? What triggers Pact verification to happen on the service side? Yep.
So there's webhooks on the Pact Broker as well, so that if you can trigger a build on your provider from a webhook, then you can set that up when the consumer publishes a Pact to the Pact Broker. It can kick the build off on the provider. Otherwise, depending on your rate of development, we just found scheduled builds on the provider worked as well. We often found that we were writing, more often than not, we were actually writing both sides. So the builds were both going regularly enough, but if you're not doing that, then you need to work out a strategy with your provider team.
Thank you.
Cool. If you do have any questions, ask them now, because I have to run off to feed those pesky babies. Cool. So there's lots of help available online if you want to find out if Pact's a good solution for you. Thank you very much, guys.